Morning, everybody. My name's Staff Sergeant John Ducelli. Welcome to the Edwards Virtual Air Show. I'm a Security Forces member here at Edwards Air Force Base, and right now I run the innovation cell for my squadron. So today I'm going to talk to you guys a little bit about innovation. I've been in the Air Force about 5 years now. I've been all over the country. I've done a lot of different jobs. For any of you guys that come on base all the time or every once in a while, those people you see checking your ID card when you come through the gate, those are my people. Those are the people that I work with. So I'm going to talk to you guys a little bit about innovation. Innovation is really the cornerstone of all the science, technology, engineering, and mathematics fields. The ability to kind of think critically and to understand the why of what we do lets us move into why don't we do things better, or why can't we do it differently? And once we start thinking like that and asking how we can do things better, we can really start moving into ideas and projects that can make life better for everyone. So today I'm going to talk to you guys a little bit about me, a little bit about my career, and then we'll talk about innovation a little bit and some of the projects that I'm working on and how you guys can start thinking like innovators. And then I've got a little game that we can all do together at the end to kind of get you thinking that way and thinking innovatively. So security forces, just to give you guys a little bit of background, we're the military police on the Air Force Base, but it goes a lot deeper than that. There's a lot more jobs. We work the gates, the people you see at the gates. We work patrol, which is pretty typical law enforcement stuff. But on top of that, we've also got teachers and instructors. We've got canine handlers that get to patrol with the dogs. And then increasingly, you've got people like me who start dealing with future technologies. And how can the Air Force of today prepare to be the Air Force of tomorrow? And so that's kind of where I come in and to think innovatively and to come up with those projects for what could be next. I chose security forces because there's a ton of opportunities, kind of like what I was talking about. There's a lot of jobs available. It's hard to get bored when there's so many different things you can do. You could be on one day, you could be on patrol. The next day you could be in the control center, and the next day you could be doing my job and trying to think of what's the Air Force going to need in 5 years. How can security forces be better tomorrow than it is today? So my first 4 years, I was at F.E. Warren Air Force Base out in Cheyenne, Wyoming. I worked on flight when I first started, just doing normal law enforcement and security work. Got to drive in Humvees, got to do a lot of cool stuff that a lot of other cops don't get the opportunity to do. And after that, I became an instructor, which was a great experience for me and kind of one of my favorite jobs so far. Not only did I get to teach other security forces members and police about law enforcement and security, but I also got to go to colleges and teach at colleges. I got to go to elementary school and teach elementary school kids a whole bunch of different things that can make their life safer or improve our relationship between us. About a year ago, I came here to Edwards Air Force Base. I went back to flight, worked patrol, worked at the gates, and then maybe 6 months ago, I started my job here in the innovation cell, which has been a super challenging, different job than I've ever been before, because you really have to think critically and think about what's next. And so some of the projects that I'm working on right now, I've got drones. So anybody out there who's ever played with the remote controlled airplanes or remote controlled helicopters, I'm working on kind of implementing something like that for us that we could do to improve our security on base. So in the next year or so, anybody coming through the gates, you might see me or some of the people I work with out there flying drones around by the perimeter, making sure that nobody's where they're not supposed to be, or somebody who's out there who's lost, we can find them. There's a lot that we can do with drones that we're really just starting to learn as an Air Force. And it's cool for me to be able to bring security forces kind of to that forefront and help us learn too. The other big project I got going on right now is self-driving cars, believe it or not. So in the next year or so, you could see cars driving around on Edwards Air Force Base with no driver, driven by a computer, just driving around. And there's all sorts of ways that we can use that, not just as security forces and police, but across the Air Force. So we're really excited to be able to kind of start testing stuff like that as well. We've talked to you guys a little bit about why do we innovate? Why did I say that this is the cornerstone of all these STEM career fields and really the topic of this week? Innovation lets us get out of stagnant ideas. It lets us stop thinking about things the way that we always have been. A lot of times you'll hear people say, oh, well, we've always done things this way, or we're going to do it this way because I told you that's how we're going to do it. But innovation really lets us kind of push that boundary and develop what's next. And especially in STEM career fields, that's hugely important. If you're not thinking about what's next from a science perspective or an engineering perspective, and especially technology, then you're sitting in the same spot and you're never going to be able to progress and you're never going to be able to learn or improve. For us specifically in security forces, it's super important. Not only as we innovate does it improve our ability to keep everybody safe and to do our job better, but it also internally helps us kind of improve our lives. It makes people happy to come into work if their life is a little better. And the better we can do things, that means the more safe the base is, the people are on base, the airplanes that we have. So it's really, by innovating, we can improve everything that we do as a career field, and not just as a career field, but across the Air Force, which is super important. For me, the innovation process kind of begins with asking why. It's easy to just say, like I said, oh, well, we've always done it this way. And we really need to learn how to ask why, which especially coming from a military standpoint can be difficult to do, because a lot of times the answer is, oh, we've always done it that way, or, oh, because somebody in charge said so. But once you kind of get into the habit of asking why and learning things, you can start to understand the problem. And once you can understand the problem better by asking why, you can ask, well, why can't we do it this way? Or why can't we do it differently? Or why can't we improve what we do? But you really need to understand the full problem before you get into that. The second biggest thing, once we've asked why and once we understand that problem, is you need to think outside the box. If these solutions were simple, everybody would have thought of them by now. It'd be easy to do. So you need to ask why and understand that problem, and then think outside the box. Well, how can we solve this differently? What can we do that's different than what we normally do? So this really is, it is really the driving force of STEM jobs. And you need to learn how to ask why, and you need to learn to think outside the box, and you need to learn to understand the problem, not just at the surface level, but really what is the driving force of that problem. So I've got a game that we're going to do with you guys out there that's going to start getting you to think about why and get you to start thinking outside the box. So I'm going to give you guys, we'll say like 5 minutes here, and I need you to find some piece of paper, something you can draw on. Doesn't need to be anything fancy, and something to write with, whether it's a pen, a pencil, a crayon, whatever works, anything for you guys to be able to kind of draw. And we're going to do a game, and we're going to get you guys thinking, how about why? And we're going to start thinking about outside the box and thinking how to solve things through an innovative process instead of what we normally do. So 5 minutes, and then we will jump right into it. So what we're going to be doing is I've got a bunch of cards here for you guys with different pictures of people on them. These people have a problem that they need us to solve. And it could range anywhere from something to wear to a cell phone that they need, or a communications device. And each person's going to have a very specific set of requirements that they need. And we're going to draw out together, or each person, right, individually, we're going to draw out a solution for them. And it can be anything that you want it to be. There's no wrong answers here, but we're going to start working through thinking critically and thinking about, well, how can I design something like this? So when I show you guys these pictures, the first thing that I want you to ask is why? Why does this person need something special? Why doesn't something we've already built work for them? because that's really one of the biggest things to think about. Is if there's already something built that can be repurposed to what they do, then that's going to save us a lot of time. It's going to save us a lot of effort in building this. But for some of them, we're going to need to come up with something totally new, and you're going to have to think outside the box. So that being said, I think we can get into the first one here. So the first one is a giant, right? So we've got this friendly giant here, and they came up to us and said they need, I'm not sure if you guys can be able to read this, but they need somewhere to sleep. So the first thing that we want to ask is why? Why does a giant need somewhere to sleep? Why can't they use a normal bed? And that's pretty easy to think through. Okay, well, they're going to be too big. They're not going to be able to fit into a normal one. So now we need to think about why they need something special. What do we need to build to meet their needs? So a couple things that are different from a giant than different from a person like you or me. The first one obviously being is that they're going to be a lot taller than us, right? So we got to think, okay, we can't have a normal sized bed. I need to be able to fit a larger person on it. Maybe they're a lot heavier than I am, right? A normal bed, the normal wood frame probably couldn't hold them up. So we need to be able to construct it out of something that this giant can fit into. So start thinking about stuff like that. What's different about them? And that's how I want you guys to kind of frame your design. What needs to be different for our friend here, for this giant? And what do we need to develop their bed to look like that's different than what my bed needs to look like? So I'm going to start drawing one with you guys, and let's see what we can come up with here. Remember, there's no wrong answers here. Anything that you can think of about why this giant needs what they have, or what's different about them, there's no wrong answers. This is what you should be thinking of. And a lot of times in the innovation process, you're going to be wrong the first couple times. You're going to hear no a lot, or we need to rethink this, or we need to try again. So don't worry about, oh, this needs to be perfect. Oh, this needs to be exactly what they need the first time. You really want to improve upon your first design. So for a first draft, as long as you're thinking about the why and you're thinking outside the box, then that's a great start. And it really lets you start developing what could be something really useful for this person. All right, so while you guys finish up, I'll show you my first idea. Hopefully you guys are coming up with something even better than that. You're really kind of thinking about the why and you're learning about it. But for me, I've got this bed frame here, right? Simple little drawing, but it's made out of steel, right? So it's heavy enough that this person can fit on it. You can see the little house down here to show how big this is. Because like I said, with the giant, we've got to think big. This person's got to be big. And they got to be able to hold their weight, which is something that's different for that person than it would be for me, or different for you or anybody else. And we've got to tailor our solution to exactly what they need so we can really develop something good for them. Some of the things to think about: colors, other uses. What else could this person use it for? If we're spending all this time designing something for them, what else could they use it for? Could this giant maybe do their homework up there? Or they could sit up there and watch TV. It's not just for sleeping. The more we design things, especially when you get into real world applications, you want to be able to think about, well, what else could I use this for? The perfect example for that is the drone program that we're working on standing up. Is it great for seeing people in areas that they're not supposed to be? Yes, it's perfect for that. But at the same time, what else could I use it for? Can I use it to take pictures of people or take pictures of events? Sure, we can do that. Can we use it to help find somebody who gets lost? Yes, we can do that. So what else, if we're spending all this money designing a special program, what else could it be used for? What else can we get out of it? What else can we maximize that with? So that's really a good thing to think about, is how else can this person use what we've got for them? So especially think about that multi-use ability of your innovation with the next one, and think about, well, not only could this work for this, but they could also use it for this instead, and they can really get a lot out of it. The next one I've got for you guys is an astronaut. So for this astronaut, they came up to us and said, I need a light source. I need a way to provide light while I'm out doing what I'm doing. So our first step is going to be to ask why. Why do they need a light source? Why can't I just give them a flashlight? And so let's think, well, an astronaut, they might be walking around outside. You can see he's got some tools in his hands here. So maybe he can't hold a flashlight at the same time. He's got to carry his box and his shovel here so he can do his job. He can't hold a flashlight too. So, okay, we realize that a normal flashlight's not going to work, and we've got to be able to develop something new for our friend here. So next thing we need to think about is what's different from an astronaut and an astronaut's job environment than my job or my job environment. The biggest one being he's in zero gravity. He's in outer space. He's going to be in cramped areas. He's going to be in a spacesuit, so maybe it's hard to move around. So this can't add extra weight. We've got to be able to make this easy to use. So think about all those things, and then I also want you guys to think about what else could he use this light for. Maybe it's not just for outside while he's working on the moon or Mars or wherever he is, but how could he use it when he's in the spaceship? How could he use it when he's on Earth? What other things can we get out of this light? So for the next one, we'll start drawing this one here. And again, just start thinking about those problems and think outside the box. What can we do that's different, that hasn't been done before to really meet this astronaut's need to make his life better? The other thing you might want to think about with this project is we already said he can't use his hands as much as he'd like to, right? Because he's using his tools and other things. So how could this light turn on without him using his hands? What could we design to make it turn on by itself? Maybe it's voice activated. Maybe he has to look a certain way, right? We got to think outside the box here, because if we just give him a flashlight that he doesn't need to hold with his hands, he still has to turn it on with his hands. So maybe that's not a perfect solution for him. What else can we do? How else can we develop this to make it better for him? And then remember, what else can he use it for? Can we add another feature to it to make it better for him, to make it fit other needs that he might have? All right, so I'll show you mine while you guys keep working, just to give you guys another idea of what I thought of here. Is he's got a nice little light up on the side of his helmet now. And like I said, maybe this needs to be voice activated. Maybe he needs to say turn on and turn off to get this to work while he's got his hands full and he can't hold it anymore. The other thing that he could do is maybe it's got a projector in it. So he can do video chats just like this with people down on Earth or back in the spaceship while he's doing his thing. He can project out what's being talked about, so he can see and talk while he's doing his job, and they can see what he's working on. By kind of thinking outside the box, you can come up with things that, oh, this is used for a couple different things that are different than what we're normally used to. Let's see what we can do for the next one here. We'll give you guys a third one before I go into questions with you guys. So our next one here is he's a ninja, right? So he's got to be sneaky. He's got to be able to get around without being seen. And let's see what our ninja friend needs. He needs an object to carry things in. So it could be a backpack, could be a briefcase, could be a duffel bag. It can be anything that you guys want. It doesn't need to be just one normal thing, because we got to think outside the box, right? So the first thing is why. Why does a ninja need this special way to carry things that's different from me? Well, like we said, the ninja, he's got all this stuff that he's got to carry around, his swords and all that stuff. You can see on this side, he's got all this gear that he's got to carry around. So we've got to think about that. This has to have a lot of storage space in it. It's also got to be able to fit while he's sneaking around. Maybe he's running around. It's got to be able to fit him comfortably. So we understand that, okay, a normal backpack that he can just go and pick up probably isn't going to work very well for him. So what can we design for him that'll work a little better? So what's different about a ninja than's different for me? Well, obviously he's sneaking around. So we've got to be able to make this kind of stealthy. Like we said, it's got to be able to carry a lot of different stuff, which is also going to be super important. And it's got to be able to be comfortable when he's running or jumping or whatever it is that he's doing karate. We've got to be able to make sure that this can stay on his back or in his arm or whatever else, wherever you guys want to make it. That's what we need to be thinking about here. So let's see. Hope you guys don't judge me too much. I'm not an artist out here. I'm a police officer, so help me out. Hopefully you guys are better artists than me. All right. So as you guys keep going, I'm going to show you a little bit about what I've got going here. So I made a little backpack that can roll itself up, and you can see it rolled up here with the backpack straps. Let me show you guys this. It's all rolled up and it's got the straps on it. And then when it's unrolled, you can see all the little pockets and spots that he's got to put all his stuff, but then he can roll it up, throw the straps on, and he's good to go. Some of the things we need to think about, especially for something like this, are things that it's easy to forget about when you're coming up with a real world solution. And one of them is color, which we talked about a little bit before, but why is that important? It can be any color, right? Well, if I gave this ninja a bright orange backpack, then it kind of defeats the purpose of him wearing all black and trying to sneak around, right? So if at first thought you're not really thinking about it, I could build a giant pink little bag here, and then I hand it to him and he's like, this is not going to work at all. And we're totally back to square one. So sometimes you got to think about things, like I said, outside the box that you normally wouldn't think of. And you're like, oh, I really wish I had thought of that the first time. One of the other things that we talked about is what else could he use this for? Instead of just being a backpack, why did I make it look like this? Ninja, while he's out doing his thing, maybe he needs to get a nap in. Maybe he's out hiding in the woods and he's going to be out there for a little bit. And maybe he could use this as a pillow or as a blanket. So now when I go back to the customer who said, hey, I have a problem with this, I can say, hey, not only does this meet what you need, but you could also do this with it. You could also meet these other problems that maybe you haven't thought of yet, or maybe you didn't think were that big of a deal, but now I can make your life a little bit better on that end of things too. So remember, ask why, right? Asking why is the biggest part of any innovation job or any innovative process, is to ask why. Why do we do things this way? Why can't we do it better? Why can't we make a backpack into a sleeping bag? Why can't we make a huge bed instead of a normal one? Don't get so caught up in, oh, well, we've always done it this way, that we lose track of what we could be doing, and thinking about what can we do today to make us better for tomorrow. So today we talked a little bit about my career. You guys learned a little bit about security forces, hopefully, and those guys that you see up at the gate checking IDs and all of that. And you also, then we talked a little bit about some of the stuff that I'm working on, and hopefully you guys will see, much more stuff coming out that makes us better at what we do. And then I talked a little bit about why innovation is important, and how to do innovation, and how to start thinking innovatively and asking why and thinking outside the box. And then we got to play a little game, which I hope you guys enjoyed, and I hope it got you kind of thinking a little bit about how we can develop solutions for people that have problems. So like I said, innovation really is the cornerstone of all STEM jobs: science, technology, engineering, and mathematics. If you're not able to innovate, if you're not able to think ahead about, well, not only do what we need today, but what do we need tomorrow? And if you can't think innovatively like that, you're going to be stuck in the same place tomorrow that you were today. So it's a super important thing, whether you're in school, whether you're doing chores at the house, whether you're working at a job, whether you're anywhere in between. Once you can start asking why and thinking outside the box, you can start developing new ways to do things. You can start getting better at what you do. You can start making your life and other people's lives a little bit easier and a little bit better for them. So this week, you're going to see hopefully a lot more speakers, and they might not be talking about stuff like this. They might be talking about traditional science, technology, engineering, and mathematics. But ask yourself why. Why did they decide to do what they did? Why did they decide to answer a question or solve a problem the way that they did? And ask them, why are we doing things this way? Why did you decide to do this? Because that's going to really help you get a deeper understanding of what they're doing, whether it's flying airplanes, rocket science, or just being security forces and working at the gate. Why do we do the things that we do, and how can we get better at doing them? With that being said, I'm going to open things up. I'm opening up here for questions.
Okay,
so
perfect.
Go ahead, ma'am.
So the first. Okay. So the first question is, how can you guys connect the computer to the car for it to move?
Okay, cool question. Let's see. So simply, they've got all of these sensors on the vehicle that help the vehicle see what's going on around it, whether that's obstacles in the road, turns in the road, other things in the road, buildings, people, you name it. So these sensors can all see that. And it's got this essentially computer brain inside the vehicle that processes all that information and says, okay, I was programmed to go from point A to point B. What's the easiest and quickest way to get there without getting out of control, without driving off the road? So it uses kind of just like Google Maps, which you guys have seen. It's just another version of a mapping system like that. So it knows where the roads are. And so then it'll plot out how to get from point A to point B. And then as it drives, all those sensors will ping and say, hey, there's another car in front of you, or there's a turn in the road here, or there's a person walking through the street. And their computer brain will say, okay, I need to then react this way. We're a ways off from actually being fully capable with that, especially on base. But some of the first things we're going to be doing is using this thing and testing it in a parking lot, in a big wide open spot where it'd be hard for something to really go super bad. But we can put it in a parking lot with cones or with dummies or, other vehicles and bicycles and see how this car reacts. And we'll be testing it to say, okay, this was a good first try. How can we make it better? How can we make this safer for the Air Force for tomorrow? So I hope that kind of answers it a little bit without getting too crazy into anything, but that's essentially how these cars are working.
Thank you so much, Staff Sergeant Dimicelli. That is all that we have for questions and answers. So then we're going to be going into our NASA activity in a second. Thank you.
Great. Well, thanks everybody. I hope you guys enjoy the rest of the air show. And remember, ask why and think outside the box. Thanks, everybody.
Start my video. What's that?
Okay, Monica, you're good to go.
Okay. I need to share my screen, please. No. Okay, now it is.
Good to go, Monica.
Thank you. Let me see. Can you see my screen? Okay. Good morning. Thank you for joining us at the Aerospace Valley Air Show. We would like to thank Edwards Air Force Base for 12 Test Wing for this amazing opportunity to live stream and connect with you. We are NASA EPDC Educator Specialists. EPDC stands for STEM Engagement and Educator Professional Development Collaborative. My name is Monica Uribe, and I'm the specialist at Armstrong Flight Research Center, and my colleague, Sara Torres, she's representing Ames, California. So we are going to talk about aeronautics. And what is aeronautics? So this is Sara and myself here in Armstrong and Ames in California. So NASA has a lot of centers all over the country. It's not just Kennedy Space Center or Houston. So we are located at California. I'm located at South California and Armstrong, and Sara is located at Ames in North California. Today we will explore what is aeronautics? Good question. So it's the science of flying. Flying what? What is flight? So how an airplane stays in the air? Another good question. X-planes, what an X in front of the planes? X for experimental. And we're gonna go and explore the NASA activities. How can I take out the video? Okay, so on this activity, I'm gonna stop my video. This activity, the objective is that the students or we will construct a small paper, a small X-plane, and launch them by blowing air throughout the drinking straw. What happens if I don't have a straw? So we do recommend you to use a paper straw or construct one using a pencil and a piece of paper. Just roll your paper around the pencil and you can get your straw. This will this will give you the thrust, and we're gonna talk about the thrust. Okay. This activity is related to one of the 3 Next Gen STEM teams from NASA. NASA has 3. One is the Small Steps to Giant Leaps, who focus in aeronautics. The second one is the Commercial Crew Program. And the last one, but not the least, Artemis. So we are going back to the moon. Focusing on the first A of NASA. When I'm asking you, if I ask you, what is NASA? What is the first thing to come to your mind? I know, rocket science, astronauts, but what about aeronautics? So the first A in NASA stands for aeronautics, National Aeronautics and Space Administration. But what is aeronautics? So aeronautics is the science of travel through good air. It's as much about you flying on airplanes and arriving safely at your destination as it is about astronauts flying in space. NASA's roots go back to the National Advisory Committee for Aeronautics. So aeronautics for NASA goes back in 1950s, 80s, when we were previously NACA, and then we became NASA. So aeronautics is a big and amazing theme for NASA. Now let's watch this video.
Monica, can you unmute yourself?
We had lady computers who reduced the data for us. The X-15 was, in many ways, the ultimate research tool. The very first aircraft to fly into space and come back and land horizontally on a runway. We had to make the engine run in order to make the plane fly. It had to be dropped from altitude, it had to be started at altitude, and it had to have stable combustion. And we made it work. It was very much an experimental, one-of-a-kind laboratory in the sky to investigate the next great hurdle, which was hypersonics. And that's a problem we're still working on today.
So we've always been trying to go farther, faster, higher. That's what mankind has always wanted to do, to explore. That's what NASA does, we explore. And now NASA is looking at a new X-plane so that we can make it a little bit easier to get across the country, about twice as fast.
And the innovation there is actually the shape of the aircraft so that we can enable supersonic flight over land. And that'll open up a whole new industry.
Here we are looking at how do we take all of those things that we've learned historically and place them in an aircraft that can actually fly faster than the speed of sound without creating the sonic boom. And if we can accomplish that objective, then people all across the United States, and in fact, all across the world, will be able to fly faster than the speed of sound. And in fact, they could fly multiple times the speed of sound without disrupting communities on the ground. We want to be at the very leading edge of technology when it comes to supersonic flight.
When you look out that window and you see that winglet, that was developed originally by NASA. There's so many things that NASA has done that we're with you when you fly.
The computers used on the space shuttle, the prototype of those computers were actually flown on the F-8 digital fly-by-wire airplane.
80% of the world's commercial airliner fleet today use that same technology in order to fly their aircraft. And almost all the military aircraft that are made today.
I remember the first time I was flying an F-18 Hornet, I was in a bit of turbulence, and I thought I was holding the airplane steady, and my flight controls were moving. Well, those technologies and those capabilities were developed by NASA.
Electric propulsion is really just opens up the playing field for what you can do with airplanes. Vehicles that be an air taxi type vehicle where 2 or 3, 4 people would travel across a downtown area and be able to get to a destination much quicker than being stuck on the freeway. And so it's going to create all new types of designs for vertical lift, transitioning to forward flight. And the predictions are that we'll be 3 times more efficient.
Unmanned aircraft systems follows in a long line of technologies that NASA always is pursuing to improve the quality of life for your everyday person, like to examine bridges or buildings that perhaps were damaged in an earthquake, find out where the damage is. You could do that by never having to actually go into the building or walk on the bridge. So that makes it safer for people.
RTP Street. That's 836 registered. For 60 years, we've been exploring. We stand on the shoulders of giants that came before us. They figured it out, and we take it a little bit farther, a little bit farther. It's what we call pushing the envelope when you're a test pilot.
And yes, some of the NASA aeronautics contribution are the winglet, wind tunnels, flight testing, because previous for being an astronaut, you have to know how to fly an airplane. On the right, you can see Neil Armstrong with the X-15, and he was a pilot, a test pilot before becoming an astronaut. What is an X-plane? So now let's talk about X-plane. So an X-plane is an experimental aircraft. On the left, we can see the X-57. That's a small experimental airplane powered by electricity. Yes, electricity. All electric technology will make flying cleaner, quieter, and more sustainable. Electric power is efficient and reliable. On the right side, you can see the X-1. This is the Bell X-1. This is the first plane to break the sound barrier. Yes, that means travel and fly super fast. The next is the X-59. This picture, and you can see on the screen, is the X-59. This is NASA's first pilot experimental aircraft in decades. Will fly faster than the speed of sound over land. The X-59 will feature innovative technology to reduce loud sonic booms to a quiet thump. This is still in development by NASA and now under construction by Lockheed Martin Aeronautics Company. We will talk about it.
So here's a couple of images on the screen, and you'll see that they're very similar, but what are the differences? Take a second just to look around and look at the different parts. You'll see that they're very similar, but if you notice very closely, you'll see that the wings are a little bit different. They're a different shape. Take a look at the cockpit and the tails. So you'll see that they're slightly different, but they're very much the same, but they're very different. So the question is, how do these airplanes stay in the air? So let's take a look at the forces that act on them so they can stay in the air. Here are the 4 forces of flight. You see that there's an arrow pointing up, and that is the lift. The airplane has to have lift. There's also weight with the arrow pointing down. There's also thrust that makes the airplane go forward, and the drag. Here's another diagram with airplane parts and functions. And you can see how they're very similar. Now we're going to watch a video about 4 forces of flight.
Monica, could you unmute yourself?
You know, Warren, I think those tests went very well today.
Oh, I have to agree with you. You know, that new engine's providing just the amount of thrust we had calculated to overcome the weight of our new aircraft?
Thrust and weight. You know, those are two of the forces in flight. Any motion through the air is the result of forces. Norval and I had to take into account all four forces in flight in order to build our airplane. Let's talk about those four forces.
That's a good idea. Okay. Let's start with the easiest force to understand. That's weight. Everything on Earth has weight because of gravitational attraction. This includes aircraft. They're always being pulled down towards the center of the Earth.
That's right, Orb. And to overcome weight, all aircraft have to produce lift. Lift is a force that counteracts weight, and it's generated by the forward motion of the aircraft through the air, creating an aerodynamic force. The shape of the aircraft, in particular, the shape of the wings and the velocity of the aircraft determine the amount of lift. The greater the speed, the greater the lift. But unfortunately, there's another aerodynamic force involved, and that's drag. Drag is the resistance of the aircraft to moving through the air, and it's also related to the shape of the aircraft, the stickiness of the air, and it's a big function of speed. The greater the speed, the greater the drag.
When we flew, we actually laid down on the wings to reduce the amount of drag. To overcome drag, we need another force, and that's thrust. Thrust is created by the propulsion system to drive the plane forward. The amount of thrust depends on the size and number of engines, as well as the way that their power acts on the surrounding air. We use propellers to drive our aircraft through the air. Most planes today, however, will use jet engines to provide thrust.
The motion of any airplane through the air depends on the relative strength and the direction of these four forces. If the forces are all balanced, the aircraft cruises at a constant velocity.
However, if there's any unbalanced force, the aircraft will move in the direction of that force. The largest force controls which way the aircraft moves.
Yeah, that sounds pretty good. But let's go try it.
Okay.
I've got an idea.
Oh, do you? Tell me.
Yeah, I think.
So if you're at home, go ahead and get out of your chair if you're standing there in your living room or in your kitchen, and let's try this out. So the technical term is pitch. But if you notice in the photograph, the young lady there is putting her arms stretched out like an airplane, and she's bending forward, and the pitch is the nose of the airplane that slants up or down. So pilots use the elevators on the vertical stabilizer to control the pitch. So if you use your body to move up and down, it's the same as the pilots use to control the pitch of the airplane. Now let's try the yaw. So the yaw is the nose of the airplane that moves side to side on the horizontal axis. So pilots use a rudder on the horizontal stabilizer to control yaw. So use your arm, use your waistline to move back and forth around and move your arms back and forth. The next one is roll. The entire airplane tilts on the left or the right. So pilots use the ailerons to control roll. So if you get on your chair, on your belly, you can have a friend or have your mom or dad help you kind of roll from side to side. So next we're going to watch a video. Actually, we're going to explore. Why don't we get into the activity? So we're going to go ahead and explore the activity. We're going to do 3, 2, 1, takeoff.
We do recommend you to utilize the engineering design process. In this process, you will create, you will ask, imagine, plan, create, test, and if you don't get the results, improve and again plan and create, and then you will share. This is a diagram from the BEST, the Beginning Engineering, Science and Technology. This process will give you to a better understanding of your design. First of all, you will need your 3, 2, 1, take off, simple activity guide. The time for this activity is 30 minutes. The materials, just a paper, plain cut off, the tape, scissors, straws, and remember, if you're using plastic straws, at the end, we do recommend you to cut it and dispose it. If you don't have drink straws, we do recommend you to build one with paper or use paper straws. These activities are aligned with the next generation science standards. Let's watch a video. 3, 2, 1, take off. The first thing, you will need your 3, 2, 1 takeoff guide. Then the materials. Ruler, straw, scissors, masking tape, and your template. If you don't have a template, I'm gonna show you how to build one. First of all, you need to cut one of the rectangles for your template. Once you have it, you're gonna fold it, and once you have folded, you're gonna grab tape and just seal it around from the top and the side. Put tape on it. Once you have tape on it, you're gonna fold it the front 4 times and tape it. Remember, it has to be sealed with tape. Just the top part and the side part. Then grab your straw. Paper straw is recommended. And you're gonna create your trust by blowing air throughout the straw. And 3, 2, 1, take off. We do recommend you to have a target. We will we create one with a lid and using some utensil from the kitchen. If you don't have a printer at home, grab a piece of paper and mark 4 centimeters on the top and centimeters on the bottom of the page. And connect them. Once you have this, you're gonna mark 15.5 from the top to the bottom. Centimeters. Remember, in NASA, we use metric system. Connect them and cut. Once you have cut, you're gonna cut a rectangular piece. That's gonna be your X-plane. Fold the piece, and guess what? You are good to draw your X59 and put colors on it. Then seal and fold the top of the paper, and you will have your X59. Don't forget the data table. Collect table. You need to collect information. Discussion questions. How is an airplane different from a glider? How is an airplane different from a helicopter? Remember, the glider has no thrust, but the paper airplane that we create, we are building our thrust by blowing air throughout the straw. How is an airplane different from a helicopter? That's a good question. The helicopter and a airplane. We have additional resources for you. You can take a picture of this screen. If you have any questions, please reach out to us. We will be glad to assist you. Thank you for joining us today. Don't forget to Google NASA, any resources, additional resources for small steps to giant leaps. Aeronautics. Subscribe to STEM Express, NASA STEM Express, TX State EPDC. And thank you for today's participation.